Good morning, ladies and gentlemen, and happy Friday. Today is May 1st, 2020, and welcome to another episode of Mr. Vasquez's online math lessons.
Lesson 8, Arcs and Sectors. We're going to be taking a look at portions of circles and talking about the area and the length of the arc. But first, I figured we would talk about just how to find the area and the circumference of a circle, just as a reminder. So here's a circle with radius 5. To find the area of the circle, the formula is pi r squared. Simply plug in 5 for the radius, we end up with 25 pi. For the circumference of the circle, that formula can be written as 2 pi times the radius, or pi times the diameter, because 2 times the radius is the diameter. For the most part, we're going to be using 2 pi r to represent the circumference of the circle. Once again, if I simply plug in 5 for the radius and combine the 2 and the 5, we get 10 pi. All the answers that we're going to be doing in this lesson and moving forward should be expressed in terms of pi. Or if you'd like, you could type in 3.14 into your calculator. But I would prefer if you leave your answers in terms of pi. So these next few questions, we are going to try and evaluate mentally. We're going to see if you can figure out the answer in your head before I reveal it on the screen. Here we have a circle with radius 8, and we're trying to find the area of the shaded portion. Well, it's clearly half the circle is shaded. So to find the area of the shaded portion, I could find the area of the entire circle and then just cut it in half. So if we're using the formula area equals pi r squared, we know that the area of the entire circle would have to be 64 pi. Cut that in half and we get 32 pi. Let's try the next one. Here we're looking for the length of the arc that goes around the circle. So the length of the arc, this case, is still half the circle. We're looking for half the circumference. So the circumference of the circle is 2 pi r, which would be 16 pi. And if we cut that in half, we end up with 8 pi. Next. So same strategy here, but this time we just have to think, what fraction of the whole circle am I looking at? Well, this looks like 1/4 of the whole circle. So the area of the entire circle would be pi r squared, or 36 pi. If we take 1/4 of that, we end up with 9 pi. Let's try the next one. Same circle, but this time we're looking for the length of that arc. Well, the circumference of the circle, if we use the formula 2 pi r, should be 12 pi. If we take 1/4 of that, we end up with 3 pi. And that is the length of the arc. So this strategy is just exactly what this lesson is going to be about. We have a circle. We're actually looking at just one portion of the circle. First of all, we call that a sector. The sector of a circle is just some portion of the entire circle. It's enclosed by 2 radii, so it always kind of meets at the center of the circle. And to find the area and the length cut off by these sectors, we really just have to think about what fraction of the entire circle is it? And then take that fraction from the area or the circumference of the circle. So for the first few, we can do mentally because it's pretty easy to picture what fraction those really were. But when we start using different angles, we have to think a little bit more about what fraction of the circle are we looking at. In this case, if you have 60 degrees, and that's the key there, the central angle is going to tell you what fraction of the circle we really have. Because we know for a fact that a circle is 360 degrees all the way around. So if I have 60 degrees out of that 360, then this must be 1/6 of the circle. So to find the area, That's exactly what I would do. I would take 60 degrees, divide that by the amount of degrees that's in the entire circle, and multiply that by the area of the entire circle. So 60 out of 360 is 1/6 of the whole circle. Then we type in 12 for the radius, simplify that down, you end up with 24 pi. Now, if we wanted to find the arc length cut off by this sector, we could do the same thing, but instead of the area formula, we use the circumference formula. So it's still 60 out of 360, but now we're going to multiply that by 2 pi r. And you notice I use the letter L to represent the arc length. So plug in 12 for r, and we turn out the arc length would be 4 pi. So now let's see if we can generalize this idea. Here we have a circle with radius r and a central angle theta. To find the area of this region, we simply need to take the measure of the central angle and divide that by 360. That's what fraction of the whole circle we're looking at. And then I just take that fraction of the area. So I multiply that times the area of the circle, and that will tell me the area of the sector. And if I want to find the length of the arc, same idea, but instead it's that fraction of the circle times the full circumference of the circle. So those are your two formulas that we need to know. Let's try one more example using these formulas. So here we have a circle with a central angle of 135 degrees and a radius of 16. So already we can kind of start to see it's getting a little hard to tell what fraction of the entire circle are we looking at. But if we use our formula, I can just simply take 135 out of 360 and then multiply that by the regular area of this circle. 135 out of 360 turns out to be 3/8, and if I multiply that by 16 squared, we end up with 96 pi. And for the length of the arc, same idea, take the fraction of the whole circumference, so that's 3/8 of the whole circumference, and we end up with 12 pi. And that's it for this lesson. Really simple, pretty straightforward. I hope this was helpful.